Hello, and welcome to Multifamily Health and Safety, Combustion Safety, brought to you by Oregon Housing and Community Services Multifamily Energy Program. So what is combustion safety? Combustion safety is a set of health and safety protocols and procedures for equipment that involves the combustion of fossil fuels. Combustion appliances may include furnaces, boilers, space heaters, water heaters, stoves, ovens, or gas fireplaces, or potentially other pieces of equipment. A combustion appliance zone, often abbreviated CAZ or CAZ, is any area of the building that contains a combustion appliance. So some basics of combustion safety. First, we want to ask ourselves, are there any safety hazards? These could include things like gas leaks, parking garage ventilation, make sure that it's functioning properly, or potentially disconnected flues. Next, how is the combustion equipment performing? Is it drafting properly? Is it producing acceptable levels of carbon monoxide? Notice that's not zero carbon monoxide, but acceptable amounts. Or could pressure dynamics adversely affect the draft of our appliances? BPI, or the Building Performance Institute, has established a series of combustion testing procedures for different types of appliances. So if you're interested in digging more into combustion testing, you really should reference the BPI standards. So let's talk about an important distinction in combustion safety, and that's the difference between CO and CO2. CO stands for carbon monoxide, which is a colorless, odorless, tasteless gas. It's the byproduct of incomplete combustion, and it's toxic. On the other hand, we have CO2, or carbon dioxide. This is also a colorless, odorless, tasteless gas. It's the byproduct of combustion, but also of respiration or breathing. CO2 is non-toxic, but it is a greenhouse gas. For the most part, within combustion safety, we're going to be concerned with carbon monoxide, or CO. One place that people have probably heard of CO is a CO alarm. So remember, CO is carbon monoxide. So when we're inspecting CO alarms, first of all, we need to make sure that we have one installed. We should also know when it was last tested and ensure that they're tested or get new batteries annually, because we want to ensure that if there's carbon monoxide in a unit, that the resident is alerted. For combustion safety testing, we also want to monitor ambient CO. Monitoring ambient CO should be done at all times when testing combustion equipment and while inside of mechanical rooms. The ambient CO monitor should be turned on outside the building to zero it out or establish a baseline. And if the alarm sounds, you should leave the space because it's indicating that CO levels are too high. In addition to carbon monoxide, we also need to perform visual inspections, starting with a visual flue inspection. So we can ask ourselves, is the flue properly connected? If we look at the image on the left, we can see pretty clearly that it's not connected. It's leaning against the wall. So if we turn that water heater on, or if it's on already, the flue gases are definitely not going to be going up the flue. They're just going to be coming out into the room, which could be dangerous. On the right-hand photo, we have another combustion appliance that has been disconnected from the flue. So again, if the appliance gets turned on, we're going to have serious problems. And it's really important that we do these inspections before we start turning things on to test them. Once we've completed our visual inspection, we should test for gas leaks. Why do we do this? First of all, health and safety. Gas leaks present a potential fire or explosion hazard, but also wasted gas. Gas costs money, and we shouldn't waste it if we can avoid it. Additionally, we need to check for adequate combustion air openings. When you're performing a comprehensive combustion safety test, we need to document that combustion air openings in terms of size, net free area, condition, and location meet code requirements. And it's critical that we check our local codes for the actual requirements because these can vary from state to state or jurisdiction to jurisdiction. Some examples of codes that regulate combustion air openings include the National Fire Gas Code, as well as the Oregon Mechanical Specialty Code. Once we've completed our visual inspections, we can move on to testing the equipment. The Building Analyst Standard from BPI requires that undiluted combustion gases be measured for CO levels, or carbon monoxide levels. We should also test the appliance for spillage of combustion gases, meaning we're testing it to ensure that the combustion gases are going up the flue instead of coming out into the room. We should also measure the draft inside of the flue for certain types of appliances to ensure that it is negatively pressurized and is pulling the combustion gases out of the building. And finally, all of these tests should be performed under worst-case depressurization, meaning you turn on as many exhaust fans as you have in the space in order to depressurize the room, the home, the apartment, or the particular space that you're in, to present the worst possible scenario that that combustion appliance would face and still be able to draft properly. There's a separate set of procedures for carbon monoxide testing for gas ovens. When we're testing a gas oven, we should always, just like in all combustion testing, monitor ambient CO in the breathing zone throughout the test. We should turn on the kitchen exhaust, if there is one, and open a window to ensure we get good air circulation. We don't need to depressurize or close everything off for this test. Turn the oven on high, usually around 500 degrees, and note the time. We then want to measure and record the undiluted carbon monoxide numbers at steady state, which is usually after about 5 minutes of operation. And you should consult the BPI standards for CO levels and required actions. This is just a preview of what carbon monoxide testing for gas ovens can look like. It's not intended to be a full-scale training. Another place that we have combustion equipment may be the laundry room. If we're in a laundry room that has combustion equipment, we should be sure to test for gas leaks, usually at the dryers, and also evaluate the dryer venting. Is the venting loaded with lint? Is it properly ducted? Are the ducts crushed? Are they clogged? And we should always check manufacturer requirements to ensure that the dryers are properly vented. This photo is an example of a real building that we went to, and this was the state of their existing dryer exhaust duct. I don't know where the dryer exhaust was going, but it certainly was not going out of this duct, which was clogged with lint for about 8 feet. So in conclusion, to mitigate combustion safety hazards, first of all, we could just eliminate combustion. This could mean selecting all electric appliances and systems in new construction, or switching from gas to electricity in existing buildings. The bonus for this is that you usually end up with lower greenhouse gas emissions, which is great. But we can't always eliminate combustion. So if not, we need to ensure that we test combustion equipment regularly, ensure our CO alarms are installed and functioning, engage with the local gas utility to address any issues that we identify, and finally educate residents about what they can do to ensure that their combustion equipment is operating safely.